In this video, we're performing naive Gauss elimination with no pivoting. So we know that matrix A times matrix X equals matrix B. We're given matrix A and we're given matrix B. So we just want to use these to solve for X. So in order to start, what we want to do is combine matrices A and B and sort of concatenate them. So basically what we're going to do is we're just going to slide B over so that it's a part of like one whole matrix. So by doing that, we get this matrix right here. So we've got matrix A and matrix B, and we've combined them. So the first thing that we want to do is we want to perform forward elimination. So in order to do this, we have one unified goal, and that is to get this sort of matrix right here, where anything to the left of this diagonal will be zeros. So we get a little triangle of zeros. So this is going to require some altering of the AB matrix, and that will be done through forward elimination. So to start, we want to get this value right here to be equal to 0. So we're going to subtract this row from this row, but we want it, here, let me show you. We want it to be so that this -3 can be subtracted out to make 0. So we're going to multiply this whole row by 2/3. So when you do that, you get 2/3 multiplied out with -3 equals -2. So you can see right now that that's going to cancel out to be 0. And then you're going to keep multiplying these through. So for example, 2/3 times 1 is 2/3, or 0.67. And you're going to continue multiplying that out. And then you're going to add it to the row on top of that to get this final row. And what's going to happen is this row is going to replace the row that was currently in spot 2 that we just altered. So you're going to get a new matrix whose second row is this row that we just created. So from there, we've just gotten this 0 right here, and we want this 7, this 7 to switch to a 0. So we're going to do the same exact thing. We're going to take this matrix, or this row, and we're going to subtract it from this row so that we can get this final position to be 0. So we're going to take top row, which begins in 2, and then the bottom row, which begins in 7. We're going to multiply the bottom row by -2/7. So that way, this value right here will be equal to -2, and this will subtract out to be 0 again. And then we're going to continue multiplying the rest of them out, and then we're going to add that through to get the rest of the row. And we're going to get a new matrix with that. So we've got 2 zeros here, and finally we want this to also be a 0. So we're going to work with the bottom 2/3 of the matrix, and really we can just ignore these 2 zeros. So we're going to work with these these 6 numbers. This is kind of going to be our new matrix that we work with. So moving on, we're going to use 9.67 and 7.86 that we just got, that were right here. And we're just going to take them and move them over here along with the rest of their row. And we're going to multiply the second row, the bottom row, by -9.67 over 7.86, so that it will be, this value right here will be equal to -9.67. And then we're going to continue on doing that through to get the new values over here, and then we're going to add them through so that we get another 0. Alright, so by doing this, we get our final matrix. This is going to replace what was previously in the last row, and it's going to go right here. So we have our final matrix, and as you see, we've got our 3 zeros, which are everything left of this diagonal, just as we wanted right up here. So we finished with our forward elimination, And now we're going on to the next part, which is back substitution. So with back substitution, I'm just going to cover up that little part. We want our x vector, or our x matrix, which we know is going to be like this with x1, x2, and x3. And so what basically happens is x1 is multiplied by the first value of a row, x2 is multiplied by the second value, and x3 is multiplied by the third value, and all of that will equal what is at the end. So we're going to do that for the first one, and as you see, since there's two zeros, we can easily have x3 times negative 3.87 is found here equals 5.72, which is right there. And so with that, we solve for x3, and that's negative 1.48. Next, we move on to the next row up here, and so it's going to be 0 times x1, and then we have 9.67 times x2, which we don't know yet, and negative 3 times x3, and we just solve for x3, so we can plug that in. So it's going to be negative 3 times negative 1.48, and that'll equal 14.33. And we solve that out, so x2 equals 1.02. Lastly, we can do it again, but this time with the top row. So we're going to plug this in for x2, this in for x3. So 2 times x1 plus 9 times 1.02, which is x2, 3 times negative 1.48, which is x3. Reminder that we've got 293 right there, and 293, and all of that will equal 9 as indicated. And so we're going to solve for x1. x1 equals 2.13. So now we have the final x matrix. So we've got x1, x2, x3, so 2.13, 1.02, and negative 1.48. And you have successfully performed Gauss elimination, naive Gauss elimination. So if you liked this video, give it a like. If there's anything I can improve on, or you just want to tell me what a great job I did, make sure to leave a comment. And if you want to see more videos like this, give me a subscribe. So thanks for watching, and I hope this helped.